Welcome, welcome, Des Moines. I live here, so this is just normal for me. This is my favorite location to give conferences because it doesn't involve airplanes and or flying halfway around the world. So, is everyone aware that they just stepped into a security discussion for the next 45-ish minutes? You signed up for this, I'm just warning you, okay? All right, I'll talk loud too. So, welcome to DevSecOps. This is a discussion, really a journey that I've been on for quite a while, from the dev to the sec to the ops space and the key controls that I kind of think should be involved throughout the entire process, and I'm just handing them to you so you can hopefully take them back into your orgs and apply them to your daily workflow. So let's do a short introduction, and I'll just live vicariously through you and explain some of my background based on who we've got in the room here. So I'm assuming, and I'll start with the first three letters in DevOps, that the majority of us are working in the dev space, maybe on a day in and day out basis. How many of you just write code, dev is your thing, you're delivering products and features to your customers just on a regular basis? So yeah, that's a solid percentage of the room. Now, I entered the dev world in the early 2000s, financial institution, basically, hey, let's build some features for the bank that, you know, makes the bank money, right? Let's sell some loans, let's actually open some accounts, do some of those things. And as I entered that space, security is not really a discussion at that point in time a whole lot. The OWASP top 10, let's say. How many of you have heard of OWASP before? That's good. When I first started doing kind of security work, and this was in 2007-ish, and I asked that same question, only about 10% of the room actually raised their hands when I asked that question. So that's how much we've at least started to discover that the security thing actually matters. How many of you do security work on a regular basis, day in and day out in your workflow? Quite a few less hands there. So in that first OWASP top 10 list that came out in 2003, we kind of looked around at our org and we said, yeah, we probably need to start worrying about security a little bit here. So we centralized some of our components, some of our, quote, high-risk code is what I call it, and we put that in the hands of maybe senior folks or people that really understood the ins and outs of product security and said, let's just centralize this and make it easy to do security right. And then I ended up on a team that did full-time source code auditing. So about 2007, I made the hard switch, and we ran commercial and or our own custom scripts to go through source code and find vulnerabilities in them. And what I saw in the world for the next 10 years is just flat out crazy. I've seen the ins and outs of things that we can just do wrong or things we can not maybe remember as we're developing our systems. And then I shifted into a role in a consulting role where I got to actually do live maybe penetration testing or vulnerability assessments where people actually hired me to go to their organization and use their systems and break in. How fun is that? And then, of course, we got to play the let's remediate the problems game when we were all done. So that's kind of the security side of my background. Along the way, I wrote a few SANS courses. Who's taken a SANS class before? Anybody? A couple hands up. So the first course I wrote, the .NET framework is near and dear to my heart. It's the first framework I wrote code in out of school. So I wrote a 4-day class just on here's all of the evil, bad things I've seen in the .NET ecosystem, what they look like, and here's how you can fix them, of course, after we attack some things. And then, as of late, the last 3 years, I've spent primarily on DevSecOps and cloud security automation. So that's kind of enough to keep me busy, but yet I have another job too, where we actually write modern code analysis software to help find vulnerabilities early on in dev life cycles, as well as in your automated build pipelines. So we run that through a company called Puma Security that's based right out of here in Des Moines. That's my background in a nutshell. How many of you do ops on a day in and day out basis? Yeah, lots of ops folks. We love that. Now, the dev side of the house, we've got this kind of DevOps process down. Operational folks, we're coming on board. Guess who's in a distant third in our discussion here on these three groups? Security. Security is always about 5 years behind everything. So this discussion really, our overall goals, I'll introduce you to a couple of resources here, and then we're just going to knock out the 4 key controls that I'll talk about. So my primary goal is to tell you, most of you are dev and ops, and you understand these things already. So this is kind of an interesting discussion for me because usually I'm talking to a bunch of security people, and I'm trying to teach them about how awesome the opportunities within DevOps are. So we're going to reverse the role today, and today I want you to take what you know about dev and ops and go teach your security people things. Bring them up to 2019, show them how easy it is to automate security scans and automate their security tasks that they're doing manually today. Teach them how to keep up, because that's really where we're failing from a product security side of the house in the industry right now. So let's talk about DevSecOps. What is it? Now the meme on this slide is pretty entertaining. If you go out to, it's like meme generator or whatever, and you search for DevSecOps, you'll get this image that says, here's what DevSecOps is. It's a unicorn and a horse and a fire-breathing dragon and a cat with a gold 9mm all at the same time. Does that sound like an accurate description of DevSecOps to you? It totally depends on who you're talking to for what the answer is. So all of you dev folks, when you talk about DevSecOps, you're probably thinking, well, it's just really product security. We've got that OWASP top 10 list, the OWASP proactive controls, the application security verification standards, the security user stories, and you're just trying to lock your products down. So if you talk to folks primarily with a dev background, that's really what you'll get back for the answer. But it's so much bigger than that. From an operational background, how many of you operations folks are writing infrastructure as code? So you're using tools like Chef, Ansible, Puppet, Salt, etc., and you're actually automatically provisioning your entire networks. How many of you have network security people that are still manually running Nessus scans against your network, and it's just slow? They can't keep up with the rate that you're actually changing your networks anymore. Your NetSec folks, when you think of DevSecOps from a network perspective, suddenly they're thinking, well, I could be provisioning our gold images that have been maybe CIS benchmark certified, for example. Or I can actually start automating the creation of our cloud infrastructure and put it into a desired state configuration that meets maybe the AWS CIS benchmarks or their Kubernetes benchmarks or the Docker benchmarks, all of those security standards that we know about, but we kind of maybe ignore on a day in and day out basis. That can all be baked in from a OPSEC perspective. And then you talk to security folks. If you talk to me and say, what is DevSecOps? I'm automating security pipelines where I can actually ingest maybe one of your URLs to one of your systems, and I can just funnel it through this entire pipeline of automated security scans to find problems continuously throughout the organization versus the traditional model, which is let's hire a pen tester twice a year and let them do a bunch of work for 2 weeks and pretend that the app hasn't changed since then. So the opportunities are endless here. Some resources that I will start you with. If this is new to you, the first resource I'll point you to, it's out on the SAND site. This was created by myself, Frank Kim, Jim Bird, and Ben Allen, primarily, at least on the right side, which is, it is zero cost. Here's all of the open source security tools on the planet that we are aware of, broken down by the phase in DevOps that you can actually apply them to. So you start at maybe pre-commit, for example, where it's like, what are all the IDE security code checkers that can give you spell check warnings as you're writing code? It can tell you about the bad things that it may be found before you've actually committed it to a repo. Or in an automated pipeline, how can you scan all of your NPM packages and find all of the vulnerabilities in those node packages before you've actually shipped this to a live environment? Those are all on that poster. There's also a cloud security top 10 that was contributed by Ben Hagan, which is if you're in the cloud, maybe here's some insecure configurations to think about, to look at your cloud code and say, well, are we doing this? Are we hiding our buckets from all the strangers out there on the internet? That would be a good place to start, right? Or how are our permissions locked down? What are our service principals or IAM roles running at from a permissions perspective? And then Ori Siegel from PureSec also contributed a serverless security top 10, which is if you're writing functions, we don't have any problems there anymore, right? We got rid of all the servers. There's nothing to patch. We don't have to worry about container security. So it's a whole new kind of top 10 awareness list of, if you're just using functions, things to think about. A pretty rock-on resource there. So that's a free PDF download. The short link's up on the top of the slide. You can go pull that down. I see a few of you taking pictures, so before I forget, these are posted on our blog at pumascan.com. So you can just go download the PDF. I believe the folks at DevOps Days will also link to them from the schedule after I give you the link, presumably, right? So you can grab these after the fact. There's lots of information in here. This slide continues down that path. So if you're really looking at security from a end-to-end continuous feedback loop perspective, this is my version of the critical security controls in DevSecOps. Starting from as you're writing code, through as you're building your apps, to running them in some sort of an acceptance environment, to production, and then into operations, gathering intel the entire way through and continually feeding that data back to the other side. So it's DevOps as you know it. It's just, what do you need to be thinking about from a security perspective along the way? So another resource you can look at, I've done several talks where I just dig into maybe 2 or 3 of these over the course of an hour. There's a couple of good PDFs that go into each of these in a lot of detail out on the SANS AppSec blog. If you're looking for those, just let me know, and I can point you in the right direction there. But this is another thing to kind of guide you in your journey as you're moving into what we call DevSecOps. Should we talk about control number 1? This is pretty high level. This is iteration 0. So you have not written a single line of code yet. What is the single most important thing you can do from a security perspective? I call it the paved road. So what does that mean? This was popularized by some of the leaders in DevOps as you know it. The Amazons, the Netflixes, the Etsy's of the world, Twitters, the Facebooks. They follow this paradigm inside of their organizations to help them move without gates, but using guardrails to actually verify that security requirements are being met. And in order to do that, from a compliance perspective, what you need to do is build your paved road out at iteration 0 that includes a lot of the security controls that you're concerned with. And that's the starting point for any new API that comes into the world, or any new gold image that spins its way up inside of your organization. It's a really important concept to bake security in by default, which then makes it really difficult for the people implementing some new system to screw it up. So what does that mean? Let's think about it from the ops perspective. If you're running VMs, let's just say you're running VMs out in Azure. What's your gold image for that VM look like? Where does it come from? How are you creating it? Does everybody get to pick their own gold image? We're just going to go into the VM marketplace in Azure and everybody just gets to select their own personal favorite name, and that's what we use and we run in production. It's an honest question. Hopefully that's not what's going on. But building out your gold image for operations is part of the operational paved road. We need to make sure that those images are secure, they're certified, they're patched regularly, and make it easy for folks to upgrade those when the time comes. We'll talk about some examples of maybe what that could look like. On the dev side, secure by default scaffolding templates. So picture this world. How many of you are writing microservices or APIs? Lots of hands go up. What's your favorite platform to write them in? This is going to be more loaded than I wanted it to be. But Azure Functions. Node.js is exploding into the world. Python. We'll just pick those few. So let's say that's your 3 primary options for folks. Picture a world where you said file, new, microservice API. And you had your 3 paved road options in that list. And every single one of them had secure by default settings already in it, implemented in the startup. Here's how to read a secret from the secrets management server. Here's how to turn HTTPS on, and it's just on by default. Here's how to do authentication, authorization, access control, set all of those security headers that you see flying all over the place, kind of on the dynamic fuzzing list, saying that you're missing those. We build those ahead of time, so then all you have to worry about is implementing your new awesome feature right here, and we don't have to deal with security in at least the whole startup part of that. And that's really what we're referring to from the paved road perspective. So on the operations side, I mentioned gold images already. What about Docker images? That's kind of an interesting thought at the moment. Did Docker have a security problem this week? Just a little one, right? And it maybe had to do with the fact that we all download images from a public Docker hub for the most part, unless you do something to stop it. And there are strangers on the internet publishing those images. Do you really know what's inside of them? So we start to pull those internally, perhaps. That's part of your paved road from a Docker security perspective. Let's get them into our internal registry and make sure that all systems are pulling those images internally rather than from Docker Hub. Just another example. We mentioned our Azure functions. So you've got secure by default Azure function. Here's the common places that we persist data to and how to do it. Here's how we want you to set up all those little secrets inside of your function and read them up at runtime so we don't have to hard code system credentials, access keys, and service principal IDs all over the place in our code. It end up causing some sort of security issue. Operationally, we can build all of that ahead of time and make it really easy to move quickly with those guardrails. So here's an example. Now this isn't the Docker problem from this week, but was there another maybe Docker problem in early February? Does anyone remember that one? Well, there was a vulnerability in the run C library inside of the actual Docker engine where if you were running from a container, you could actually overwrite the run C library on the host and get root access to the host Docker engine itself. So that's a 0-day. What did you do after you swore for a second? Because you realized you had a lot of work to do. Now, we run several container clustering servers out in the cloud, so I just threw, this is part of a paved road template that we've got powering all of our cloud accounts. So we have a new cloud or a customer come on board, and we clone our paved road ops repo that's full of CloudFormation templates for AWS, and we just point, click, and shoot straight out into the new cloud account. We've got everything provisioned in there, ready to rock, from VPCs to NACLs to security groups to policies to API gateways to container clusters. It's all created, provisioned, and secured within about 30 minutes. And that's how we create all of our cloud accounts. So in that moment, yes, I'm like, okay, I'm going to have to spend an hour patching hundreds of container cluster instances in our accounts. No big deal, right? As simple as a git clone, I edit one line of code, which is the actual gold image ID that's running the actual Docker agent on it. And I update that ID to the new patched version, and I do my git add, git push, and it shoots that template into a pipeline that then goes out and automatically creates new secured patched instances, and it tears the old one down. Took me maybe an hour to roll my entire fleet of container instances over in a 0-day scenario. Is there any better definition of DevSecOps right there? And we didn't really do anything from a security perspective, did we? We changed an IDE. That's just DevOps. That's what we're here for, right? We love this stuff. So go teach your security people how to do this. Because that's the most powerful thing you can set up is that paved road ahead of time. Now, I put some other interesting things to think about on this slide. Since we're staring at a launch configuration for a VM, your security folks, they're probably going to be pretty interested in maybe what that instance profile is that that's running under. That's your service account. What permissions does it have? Also, potentially, that key in the middle. You know, who has admin access to SSH to this box? These are things we can control in source code if we set this up correctly with this paved road. So lots of good examples, things to think about from a security perspective there. But you've got full visibility into them if you set the paved road up ahead of time. We'll talk dev here for a minute. We'll bounce back and forth between dev and ops and sec, over the next half an hour. On the dev side, this is pretty loaded as well because we already mentioned there's a splattering of frameworks out there. So the more frameworks that you have inside of your organization, you've got that number of paved roads that you need to build ahead of time. So this is difficult to keep up with, especially in the world of functions and microservices where you've got this polyglot explosion of different platforms internally, but somebody has to do it. Just ideas for your template, what to think about. How many of you have seen secrets management screwed up in some fashion inside of your organization at some point in time in your career? Everyone should be raising their hand. So it'd be great if that template said, hey, Eric, when you need to read some secret, here's the example of how to do it, and it's already pre-wired and pre-configured. That would maybe tempt me to not hard code the AWS access keys in the Docker file, right? If I knew it was that simple. So that's something that should definitely be in there. Enforcing access control and authentication and authorization across the board in the template from the dev side would also be huge. If it made it very clear, here's how to do it. So you're just laying examples to stop maybe folks that aren't familiar with this from making mistakes. And on the security side, I love it because now I know what to look for. I know that there should be a line of code enforcing authorization for every single entry point to this microservice, and guess what I can search for now from an automated pipeline? I can tell if you turned it off. And we can start to do actual enforcement in our automated runs of this, which is in the next section. We'll get to that again here in a moment, but just ideas to think about here. I pulled this out of one of our .NET Core paved road templates, and it's just a very small subset, just to give you an idea of what we can be looking at in here, but it enforces password complexity. So right out of the gate, no one will ever be able to register an account with some weak password in this system. No one else has to think about it. I know it meets our policy. It's in the section that says nobody change this thing. HTTPS, the security headers. We've also got authorization and entitlement checks. All of these can be pre-baked into the paved road template, so when you go clone it to start your new API, it just says, hey, implement your new awesome thing here. Don't touch anything else. Sounds so simple, right? Iteration 0. Takes a lot of work. What do you think, though? If you do that across the board for all new ops, networks, cloud infrastructures, and products that are rolling out the door, how are you feeling from a security perspective? Not bad, right? So that's goal number 1. Start the journey. That's a years-long journey I just ripped through in 10 minutes. But it's an important one to take away. Next up, this one's pretty straightforward. How many of you have implemented or ran some sort of automated pipeline before? I love that. The security folks are terrified of these things because they don't understand the tool chain. They don't understand how they work. Traditionally, security is very used to going to web interfaces or some sort of UI and clicking buttons and setting up security parameters and hitting go and letting a scan run for a couple hours. Make them feel useful, right? And then they wait for the results to come back. And in this section, my entire goal for you as DevOps folks already is just to understand that in your organization, there are security tools, and if they are worth anything, worth purchasing, 100% of the functionality is available through an API, which means what? We can plug them into this, right? So the whole goal of this section is just to start automating security and compliance so you are doing continuous security assessments of your systems. Now the pipeline on the slide, that's a Jenkins pipeline that's building and provisioning our entire cloud infrastructure for us. Hundreds of resources being pre-created. In every single build, we are continuously scanning them for vulnerabilities. So Step one is just the very basic peer review. Every time we change, this is high-risk code, right? If this is building and provisioning hundreds of cloud accounts, you probably want some eyes on this from a peer review perspective. Specifically, somebody that kind of understands security at the same time. How many of you do peer reviews regularly in your organization on all code changes? How many of you would know what a security vulnerability looks like if you found one of those in your peer reviews? Everybody put their hand up, right? Think about the security side as you're doing that, because this just integrates right into your workflow. It might take a little bit of training on maybe some of the cross-functional teams to say, hey, look, there's a checklist of maybe 10 security things I just want you to start looking for and commenting on, like putting the access keys in the Docker file. Or maybe in this example, I caught during a peer review somebody downgrading the SSL TLS cipher suite policy on one of our load balancers. And that's why that's highlighted in red. And we can immediately put feedback in it that says, don't do that. If users are still on IE6, they're not allowed to use our system anyway. Tell them to get a new machine or upgrade. So we keep the TLS 1.2 policy there. That peer review process, that doesn't really change whether you're in DevOps or DevSecOps. It's just looking for a few extra things. So that's step one in the CI/CD process. It's not getting to the automated build unless we pass this phase. And then we run some automated code linters. Okay, that sounds cool, right? Is anybody writing Terraform or CloudFormation code to automate and build things? Lots of hands go up. Is anybody running Terrascan or CFNNAG to look for security issues inside of those templates? Yes, one hand up. This is the CFNNAG scan result that scans our cloud infrastructure. It looks for things like wide open security groups, SSH access to servers, maybe me allowing some sort of missing logging on a CloudFront distribution, for example. It tells you all of that, and we can report on that and trend on that data inside of our automated pipelines. That's nothing new, right? Everybody's seen JUnit formatted output before. We're just turning the security data into the right format so we can get a nice, pretty visualization of here's what we found during the scan. We also can archive those artifacts, that's huge from a compliance perspective. Is anybody doing continuous kind of compliance audits inside of their org? Anybody on the compliance side in here? A couple of hands up. Wouldn't it be nice if you had to do an audit on a system and you just went to the latest build of this cloud infrastructure and you saw every single compliance report that you needed to run against the system, it was just sitting there ready for you to download it? So become friends with your auditors. Figure out what they need to help their jobs move a little bit more smoothly. And you can work together to get the right reports there, and then guess what? The auditors will stop bugging you, and you can get work done. Sounds cool, right? So extending that from a security discussion is prerequisite number 2. Number 3 is a loaded concept. We could talk about this all day if we wanted to. I call it the supply chain problem. And as we dig into this, hopefully you'll understand what I'm referring to. But this can just be rephrased as downloading code from strangers on the internet. And then running them on your production server. That's even better, right? So there was an interesting talk from Adam Baldwin last week at Loco Moco Sec. Has anybody heard of that conference? If you're filling out conferences to get funding to go to, I'm just going to tell you next year it's in Maui. It's actually in Hawaii every single year. They just hop islands. So food for thought. It's all security stuff, but it's probably worth a trip to Maui just, in itself, right? You can deal with the security side of it. But Adam Baldwin is one of the lead security researchers for the NPM project. In his talk, basically he said, when somebody writes a Node service or API or a Node app, 97% of the code that's running inside of that thing were downloaded through NPM packages. So you own 3% of the code, the other 97% you downloaded from strangers on the internet. What could go wrong? Everything. There's been some awesome examples, and I'm sorry I'm picking on Node. If it's your favorite platform, it's the way it was built with these Node packages. There was an open source node package maintainer that got social engineered a couple of months ago into allowing an attacker to take over the maintenance of the repo. They sent him an email and said, hey, you look like maybe you're getting a little tired of working on this open source project and not getting paid to do it because you haven't made any commits lately. I'd be happy to take over the maintenance for you and just take this burden off of your back. There wouldn't be any disgruntled open source folks out there that just get tired of dealing with people that think they're customers, right? So we said, yeah, sure, you can take it over. That's awesome. I've got like family, I've got kids. I maybe go outside, see the sunlight every now and again. You do it. And the first thing they did was put a backdoor into that package that stole NPM API creds from anybody that did an NPM update. As soon as you ran that, you got malware on your laptop. That sounds cool, right? That's the supply chain issue from the app level. Now, this isn't just Node. Your Javas, your .NETs, those are all pulling in similar packages there. We've already picked on Docker and Docker images, so we won't revisit that. But this extends a little bit further than that. Azure and Amazon have marketplaces for their VMs. So you can actually spin up VMs in your cloud account from strangers on the internet. What could go wrong, right? Highlighting the importance of gold images. Where else can we get strange code from? This just keeps going. There is a serverless function marketplace in the Amazon ecosystem. So you can actually download serverless functions from strangers on the internet and run them inside of your cloud account. What could go wrong there? Better yet, those serverless functions are downloading packages under the hood from other strangers on the internet too. There's two supply chain risks there. There is an AWS WAF marketplace. So now you can download web app firewall rules from strangers on the internet and use them to run your web app firewall inside of your cloud account. That sounds pretty fun, right? Should I keep going, or is everybody on the same page here on what this actually means? We'll do one more. Has anybody downloaded gold image templates from the Chef Supermarket or Puppet Forge? Do you already know where I'm going with this? It's crazy, right? Just keeps going. The world of open source is awesome, but we can't put blind faith in the fact that somebody that maybe is more malicious didn't put something in that thing that can harm us. In my opinion, this is the largest issue we're facing from an IT security perspective at the moment. So what can we do? I'll give you some tools here, at least to start figuring out what your inventory is and figuring out if there have been actual known published vulnerabilities with these things. On the app side, there is a free, completely open source tool called Dependency Check. Is anybody running this already internally? A couple hands up. Hopefully next week everyone will raise their hand because this is a free open source zero cost tool that will tear apart your Node, your Java, or your .NET package references. It will inventory them. It will figure out what version you're running. And then it will download the entire MITRE CVE database and it will cross-check it to see if there are vulnerable packages in your system. And it will tell you about it. Sounds like good information to know about ahead of time, right? There's a couple other ones listed there. But the whole takeaway here is start scanning your app dependencies and figure out if you're running struts 1.x, for example, in production. No one would ever do that in real life, right? So here's what that looks like. We use prerequisite number 2. We plug that into our CI server. Now you've got parsable intelligence in your CI server where you can actually say, look, if any CVEs over a score of 7.0 pop up in this scan, we maybe need to stop the build and look to see if we can actually upgrade the component version and patch the vulnerabilities in our system with a new version of whatever the package is. So that's using prerequisite 2 and 3 to achieve more security. Same thing on the Docker image scans. Now there are lots of open source tools. I won't really talk about vendor solutions a whole lot in this talk, but Encore and Claire are probably my top 2. If you're building Docker images, you should at least be scanning them with one of these 2 open source tools that can tell you about all of the libraries in your image that have known vulnerabilities in them. Same game, it's just picking apart the layers in an image and looking at what is in the image itself. Now, side note, Claire was created by CoreOS, who got acquired by Red Hat, who then got acquired by IBM. So the full name is IBM, Red Hat, CoreOS, Claire. And I have no idea what the future for that is. IBM could make that more of a commercial offering and part of the Red Hat OpenShift platform. We don't really know yet. But as of right now, the maintenance is still looking pretty good, and it's looking pretty solid. It's a good scanner. So plug that into your Docker scanning infrastructure. Again, extended into prerequisite number 2. Plug that into your automated build pipelines, and now you've got reports. You know what your Docker image security posture looks like. Has anybody scanned one of their images before for vulnerabilities like this? Were you terrified when you saw the results? It's scary, right? Default images from vendors have like 90 to 100 open vulnerabilities inside of different libraries. It's terrifying. So make sure you're running those. I will mention 2 other projects here, and these are both open source projects. You can go start with this for building your gold images using Chef, Puppet, and Ansible recipes, or Ansible playbooks, I mean. The first one is the DevSecIO project. So go out to dev-sec.io. This has pre-created, pre-vetted, by the security community, hardened templates inside of them for meeting some of the regulatory requirements such as CIS, DSIS, GAP, STIG, some of those mandatory compliance. You're nodding your head, right? Auditors love this stuff. So let's say you need to be CIS level 1 benchmark compliant on all your CentOS 7 VMs. You go out to DevSecIO and you choose, do I want Chef, Puppet, or Ansible? And you can download a pre-created template for CentOS 7 that is certified to be CIS level 1 benchmark compliant. And that can be the beginning of your paved road for your CentOS 7 gold images. Now, just food for thought here, is that still code that's written by strangers on the internet? You still need to read them and do your due diligence there. But there are a lot of security eyes from the security community on this looking for backdoors and evil things that could potentially show up. So better than just the random template from the real stranger, but again, still open source. Taking it a step further, the second one on the slide is the SIMP project. This is more for the DoD space. So if you need those extra hardened images, like your FIPS 140-2 compliant images, you can actually go out to the SIMP project and download Puppet manifests that are compliant with some of the DoD regulations from that project. Those are sitting there waiting for you to start your operational paved road journey from an infrastructure as code perspective. So 2 really good projects from an automated infrastructure perspective there. Good stuff, right? Okay, let's talk about one more supply chain issue. This is actually one of my favorite ones. This has to do with Lambdas in AWS. Who's writing serverless Lambda functions? Lots of hands are going to go up. Did anybody see the announcement at reInvent in December where they said, we're introducing this new concept called layers? Is anybody using Lambda layers? A couple hands up. So what this is assume that this is your entire function here. You can actually inject centralized packages inside of the execution environment before your code is actually pulled into it and executed. So from a supply chain perspective, my first thought was, well, that's cool. Because let's assume we've got that node function. I can actually approve and centralize all of the node packages into a layer that I'm in control of, and you can just reference my layer. And my CI pipeline can block any other packages from being pulled into that function. So now I'm in control of all of those NPM packages and the security of them outside of your function. Sounds like a good, maybe security control, right? And then you read a little bit further, and it says, oh, by the way, you can create a layer, and you can share it with other AWS accounts. So now you can create malicious layers with malicious packages and publish them, and you can download them into your functions from strangers on the internet. So there's the red team point of view. Back to the blue team point of view, a couple vendors, PureSec being one of them, actually open sourced a tool called Function Shield that provides security protections inside of your execution environments via a layer. So you pull in their Function Shield layer, and you can configure it in your function and say, let's turn on these maybe 5 security features. One of them blocks all outbound connections from your function. That sounds like a cool security protection, right? So if I inject malware into your function and it attempts to make a command and control connection back out to ericsevilserver.com, Function Shield just blocked that malware from actually being able to talk back to home base. That's cool, right? Another option is making the file system completely read-only inside of the execution environment. So I can't persist my malware into the temp directory and then run it from maybe some other vulnerability inside the function. So that's another cool blue team point of view just on Lambda layers itself, but just be aware that also falls into our supply chain responsibility. Kind of fun, right? Is anybody terrified of the supply chain now? I am every day, if it makes you feel any better. All right, we've got a few minutes left here. Operations is section 4, and it's really about continuous security compliance. This just extends the CI/CD discussion. Help your auditors out and figure out what tools they are running and burn them into your automated builds and acceptance scripts. This will achieve continuous security compliance and make you fully aware if some cloud infrastructure or some gold image or some application drifts from your security baseline. So by automating these tools, and there are lots of them out there, it enables us to know immediately if we're not compliant. We can set up stories or unit or acceptance testing scripts to help achieve this. And I'll mention a couple tools here in a second that help you automate some of this. And then our auditors and compliance folks suddenly become a little bit more comfortable with this whole DevOps notion because we're being nice to them. We're including them in the workflow, right? So some tools here. The first thing I'll mention is inspec. Is anybody writing inspec stories already for compliance? Probably one of the coolest things ever. It's great. The compliance folks can actually contribute here as well. These are very human readable stories that says, by the way, this file should exist on the file system, or the permissions should look like this, or this resource in the cloud account should either exist or not exist. And you can wrap these stories up into a compliance profile and just do an inspec exec on the profile and run that just like a unit test suite. Do you remember that DevSecIO project I mentioned? They've got pre-hardened profiles out there to take that CentOS 7 gold image and actually run a verification against it to make sure it is actually CIS level 1 benchmark compliant. There's profiles out there for your Nginx servers, your Apache servers, your MySQL servers, looking at all of the different security settings on that system. You can use inspec to automate that. OpenSCAP is another one. On the cloud side, is anybody running Cloud Custodian? No hands up. One hand. Oh, the very back. Yes. Pretty awesome, right? This is open source by Capital One. Capital One, has anyone talked about Capital One's DevOps journey before? Seen any of their talks at conferences? A massive shift into the cloud. When they got there, they realized that AWS config just didn't cut it for them, because that's your desired state configuration service in AWS. So they wrote their own. They open sourced it. And it's got profiles that you can write to say, no S3 buckets can public read inside of this account. And it continually evaluates all of your resources in the cloud, and if you create a bucket that's got public read on it, guess what it does? It'll notify, number one, and if you tell it to, it'll just kill the bucket off the second that it finds it. And Capital One is using that to achieve continuous security compliance inside of their entire enterprise across all of their cloud accounts. So it's being very well maintained because they're dog fooding it internally. That's continuous cloud compliance in a nutshell. Other tools for that, Scout Suite and the AWS CIS benchmark scanner, again, all can plug into your automated compliance scans. So here's an example. This is probably a little difficult to read for the folks in the back. So pull down the PDF, but this is how you can run the Linux security baseline profile from Inspect and generate your pass-fail results right in the bottom part of the slide. Now that's console output. That kind of sucks. So your next step would be to format that into our friend the JUnit test. Does that look familiar? Yeah, I already showed you one. That was cloud code scanning. Now we've got actual Inspect results. Your auditors can go in and view all of the passing and or failing test cases from a compliance perspective generated by Inspect inside of your build pipelines. So we plug that in. We've got the gold image covered. The Docker images are all covered by Inspect profiles. It's got a resource pack for Azure's CIS benchmark security compliance spec as well, but the actual profile you'll have to write on your own. The profile itself is part of Chef Automate, their compliance platform, but it's not been put into the open source repo yet. So lots of cool features available in there. Finally, this is another desired state config automated compliance scan. This is dashboarding that's running out of an AWS account looking for security compliance in AWS. Just lots of examples to get your thoughts kind of thinking towards what can you help security people accomplish that they're constantly bugging you about. Get it automated and get it out of the way. With that, I know I just dumped about 6 months worth of data onto you, but that's just how I roll. So the slides are available. We probably have time for maybe a question or two. I think I'm a little bit over. So if you have anything burning, feel free to shout it out. Otherwise, I'm around all week as well. I've got some stickers and stuff with me too that I'm happy to hand out. So anybody have questions? So the slides will be on the actual DevOps Days site. There'll be a link there. If you go out to pumascan.com and look in the blog, there's also a blog post with a link to download the same sort of deck as well. This is a little off topic. Yeah, I'll let you all free. We'll chat. Yeah, thank you.